Hello my dear students, welcome back to chemistry online class. So in the previous class I have explained to you about the atomic mass of an element concept and the second concept called as the molecular mass of the chemical substance. Atomic mass of an element concept. In that atomic mass concept, the definition of atomic mass is discussed in the last session. Then the unit used to express the atomic mass of an element, then gram atomic mass of an element part, or we call it as a gram atom, or it is also called as a mole atom concept. In addition to all these important points, one more important term used under atom concept is the average atomic mass of an element, students. And you please recall the average atomic mass of an element part. So this average mass of an element, average atomic mass of an element is an atom exists in two isotopes with atomic mass A and atomic mass B in the ratio m is to n. In such cases, the average atomic mass of an element is calculated by using the formula m into A plus n into B, denominator m plus n. Suppose an atom or element exists in three isotopes with atomic mass A, atomic mass B and atomic mass C. In such cases, the average atomic mass of an element is calculated by using the formula m into A plus n into B plus O into C, denominator m plus n plus O. Like this will calculate the average atomic mass of an element, students. And with the help of this atomic mass concept, one more terminology called as a molecule. So in that molecule, the definition of a molecule is discussed, then classification of molecules. So two different mode of classification is over, and one more terminology called as molecular mass of the chemical substance, students. And already in the last session only we discussed how to calculate the molecular mass of given chemical substances. And please recall these steps in the molecular mass calculation. The first step, identify the types of atoms present in the given substance. The second step, write the number of each atoms present in the given chemical substance. And the third step is multiply each number of atoms present in a given substance by their respective atomic mass. Now the fourth step. So add the atomic mass of each atom present in a given substance. You will get the total mass of the chemical substance. And this total mass of the chemical substance itself we call it as molecular mass of the chemical substance, students. And you please remember this molecular mass of the substance, it is an additive property, and this molecular mass it is calculated or it is determined by the sum of atomic mass of different atoms present in a given chemical substance. That is regarding the molecular mass concept, students. And already you know how to calculate the molecular mass of the different chemical substances. And you please remember this molecular mass concept. It is very important in mole concept. It is important in the stoichiometric calculation, and the same part is important even in case of percentage calculation of element also. Okay. Now with the help of this atom then molecule. With the help of this atom and molecule, so in the today's class we'll discuss about the additional information related to the atomic mass and the additional information related to the molecular mass of the chemical substance for the competitive examination point of view, that is for NEET and JEE. Okay, and here in case of atomic mass of an element concept, in case of atomic mass of an element concept, there are different methods of determination of atomic mass of an element, students. The number of methods are used to determine the atomic mass of an element, and out of these different methods, the first method is called as Dulong and Petit's law or Dulong and Petit's method. And according to this Dulong and Petit's method, according to this Dulong and Petit's law, the atomic mass into specific heat is equal to 6.4. The approximate value 6.4. This is the main important formula, students. You please remember this formula. According to this Dulong and Petit's method, so atomic mass of an element which is multiplied by specific heat which is equal to 6.4. And if you rearrange this expression, so this implies the atomic mass of an element is calculated by using the formula. So atomic mass equal to 6.4 divided by specific heat, students. And you please listen the word specific heat here. I think already you come across this word in your lower class as well as the same word so in the physics part also. Specific heat. Yes, students, anyone what is mean by specific heat? Yes, tell me, students, anyone what is mean by specific heat of a substance? Yes, the quantity of heat required to raise the temperature, of a body. That itself we call it as a specific heat of a substance. I repeat the definition. So specific heat, what is mean by specific heat? It is defined as the quantity of heat required or the amount of heat required to raise the temperature of a body, to raise the temperature of a substance. That itself we call it as a specific heat of a chemical substance, students. So here to calculate the atomic mass of an element, the relevant formula is atomic mass equal to 6.4 divided by specific heat. Here the Dulong and Petit's method or the Dulong and Petit's law, it is applicable only for the solid elements, except beryllium atom, except boron atom, except carbon atom and except silicon element or silicon atom. Why this law is not applicable in these four cases, students? Because in all these four elements or in all these four items, the specific heat varies with the temperature. The specific heat of beryllium, boron, carbon and silicon. So the specific heat of all these four atoms or all these four elements varies with the temperature. So that's why the Dulong and Petit's method is not holds good for these four elements, students. What are those four elements? Beryllium, boron, carbon and silicon. And you please keep it in mind, the law is applicable or the law holds good only for the solid elements. And the second important method of determination of atomic mass of an element, the second method is vapor density method. And this vapor density method, it is applicable for the elements whose chlorides are volatile. Listen the sentence carefully. The second method is applicable for the elements whose chlorides are volatile. Please recall the chemical substance. In case of a chemical compound or in case of chemical substances, two different types. One is a volatile substance and second one is a non-volatile substance. Volatile and non-volatile. Volatile means the substance one which easily gets evaporated. Such type of the substances are called as volatile substances. Please listen the words carefully, students. ನೋಡ್ರಿ ಇಲ್ಲಿ ಒಂದನ್ನ ನಾವು volatile compound ಅಂತೀವಿ, ಇನ್ನೊಂದನ್ನ ನಾವು non volatile ಅಂತ ಕರಿತೀವಿ. Volatile compound ಅಂದ್ರೆ ಏನು? The substance one which easily gets evaporated. In such cases we call it as a volatile substance, students. Whereas on the other hand, non-volatile. So non-volatile means the chemical substance one which does not easily gets evaporated. In such cases we call it as a non-volatile. ನೋಡ್ರಿ, ಒಂದು ವಾಲಟೈಲ್ ಇನ್ನೊಂದು ನಾನ್ ವಾಲಟೈಲ್. ಹೌದಾ? ವಾಲಟೈಲ್ ಅಂದ್ರೆ ಏನಪ್ಪ, ಈಸಿಯಾಗಿ ಎವಾಪರೇಟ್ ಆಗೋದು. ಹೌದಾ? ಈಗ ನೋಡಿ, ನಾವು ಜನರಲ್ ಆಗಿ ಏನಂತೀವಿ, ಕೆಮಿಸ್ಟ್ರಿ ಇಸ್ ಅ ವಾಲಟೈಲ್ ಸಬ್ಜೆಕ್ಟ್. ನೋಡಿ, ಯಾಕೆ ನಾವು ಕೆಮಿಸ್ಟ್ರಿನ ವಾಲಟೈಲ್ ಸಬ್ಜೆಕ್ಟ್ ಅಂತ ಕರಿತೀವಿ ಅಂತಂದ್ರೆ, ಈಗ ನೀವು 2 days ಅಥವಾ 3 days ಏನಾದ್ರೂ ಕೆಮಿಸ್ಟ್ರಿನ ಓದ್ಲಿಲ್ಲ ಅಂತಂದ್ರೆ ಕೆಲವೊಂದು ಕಾನ್ಸೆಪ್ಟ್ ನಮಗೆ ಈಸಿಯಾಗಿ ನೆನಪಾಗ್ಬಿಡ್ತಾವೆ. ಯಾಕಂದ್ರೆ ನ್ಯೂ ಟರ್ಮ್ಸ್ ಇರ್ತಾವ, ನ್ಯೂ ಟರ್ಮಿನಾಲಜೀಸ್, ಕೆಮಿಕಲ್ ರಿಯಾಕ್ಷನ್ಸ್, ಬ್ಯಾಲೆನ್ಸ್ಡ್ ಇಕ್ವೇಷನ್ಸ್ ಎಲ್ಲ ಇರ್ತಾವ. ಹೌದಾ? ಸೊ ನೀವು ರೆಗ್ಯುಲರ್ ಟಚ್ ಇದ್ರಿ ಅಂತಂದ್ರೆ ಈಸಿಲಿ ವಿ ಕ್ಯಾನ್ ಗ್ರಾಸ್ಪ್ ದಿ ಕಾನ್ಸೆಪ್ಟ್. ನಡುವೇನಾದ್ರೂ ಗ್ಯಾಪ್ ಆಯ್ತು ಅಂತಂದ್ರೆ ಈಸಿಯಾಗಿ ಏನಾಗ್ಬಿಡತ್ರಿ, ಮರೆತು ಬಿಡತ್ತದ. ಹೌದಾ? ಅಂದ್ರೆ ಕೆಮಿಸ್ಟ್ರಿ ಇಸ್ ಅ ವಾಲಟೈಲ್ ಸಬ್ಜೆಕ್ಟ್, ಹೈಲಿ ವಾಲಟೈಲ್ ಸಬ್ಜೆಕ್ಟ್ ಅಂತ ನಾವು ಟರ್ಮ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಸೊ ಇಲ್ಲಿ ಸಬ್ಸ್ಟೆನ್ಸ್ ಕಾನ್ಸೆಪ್ಟ್ ಒಳಗ ನಾವು 2 different categories. One is volatile, second one is non-volatile. The substance one which easily gets evaporated is called as a volatile, and the substance one which does not easily gets evaporated is called as a non-volatile compound or non-volatile substance. Students, and here the second method we call it as the vapor density method. So this vapor density method, it is applicable only for the elements whose chlorides are volatile. Please listen this sentence carefully. Whose chlorides are volatile. And here, according to this vapor density method, the valency of an element is equal to molecular mass of chloride divided by equivalent mass of chloride. Students, listen the formula carefully. How to calculate the valency of element? Here, molecular mass of chloride divided by equivalent mass of chloride. So what is mean by equivalent mass? That we'll discuss later. Here you just remember the formula: molecular mass of the chloride divided by equivalent mass of chloride, or molecular mass, it is nothing but 2 into vapor density. Molecular mass is nothing but 2 into vapor density. So in place of molecular mass, let us write 2 into vapor density of chlorides divided by equivalent mass of metal plus 35.5. Please listen this formula carefully. ನೋಡ್ರಿ, ಯಾಕೆ ನಾನು ಇಲ್ಲಿ 35.5 ಬರ್ದಿದ್ದೀನಿ ಅಂದ್ರೆ, this is nothing but the atomic mass of chlorine. ಹೌದಾ? Cl ದ atomic mass is 35.5. ಇಲ್ಲಿ ನೋಡಿ, equivalent mass of chlorides. Chlorides ಅಂದ್ರೆ ಮೆಟಲ್ ಕ್ಲೋರೈಡ್ಸ್ ಇರಬಹುದು. ಹೌದಾ? ಮೆಟಲ್ ಕ್ಲೋರೈಡ್ಸ್ ಅಂದ್ರೆ ಇಲ್ಲಿ equivalent mass of metal plus 35.5. So this is the formula. And here atomic mass, the atomic mass of an element, it is generally calculated by using the formula equivalent mass multiplied by valency. Listen this point carefully. How to calculate the atomic mass, students? Equivalent mass multiplied by valency. So what is mean by equivalent mass? How to calculate the equivalent mass for the different chemical substances? That we'll discuss later. Here you just remember, in case of vapor density method, so the method is applicable only for the elements whose chlorides are volatile. So here the formula is valency of the element is equal to molecular mass of the chloride divided by equivalent mass of chlorides. And in place of molecular mass means it is nothing but 2 into vapor density. So 2 into vapor density of chloride divided by equivalent mass of metal plus 35.5. Students, so this is regarding the valency of the atom. And how to calculate the atomic mass here? The atomic mass of an element is calculated by using the formula equivalent mass multiplied by valency. This is regarding the second method called as vapor density method, students. And the third important method is a specific heat method. And listen, this specific heat method, it is applicable only for the gases. This method, it is applicable only for the gaseous elements. only for the gaseous elements. There are two different types of specific heats. One is Cp and the second one is called as Cv. First one is Cp and the second one is Cv. Cp and Cv. One is at constant pressure and the second one is at constant volume. The specific heat at constant pressure and the specific heat at constant volume. There are two different types of specific heat. One is at constant pressure and the second one is at constant volume, students. And here, according to this specific heat method, according to this third important method, the atomic mass of gaseous element, is calculated by using the formula molecular mass of the chemical substance divided by atomicity. Listen the formula, molecular mass divided by atomicity. The one more term, atomicity. Listen this word carefully. Atomicity, it is nothing but the number of atoms present in a given molecule. That is regarding the atomicity, students. So what is mean by atomicity here? The number of atoms present in a given molecule is called as atomicity. Let us take an example of H2O, water. How many atoms are present in this water molecule? So 3 atoms are present, 2 hydrogen atom and 1 oxygen atom. The number of atoms present in a given molecule is called as atomicity, students. So according to this specific heat method, so it is applicable only for the gaseous elements. And there are two different specific heat. One is at constant pressure, that is Cp, and the second one is at constant volume, that is Cv, students. And according to this method, the atomic mass of a gaseous element is calculated by using the formula molecular mass of the chemical substance divided by atomicity. Okay, and now coming to the fourth one, the fourth important method of determination of atomic mass. The fourth method is called as isomorphism method. Listen this fourth method, isomorphism method. And here, this isomorphism method, according to this isomorphism, the law of isomorphism, according to this isomorphism law, it states that the compounds having identical crystal structure. Listen the word carefully. The compounds having similar crystal structure or identical or same structure have similar constitution and chemical formula. That is the statement of isomorphism, students. Please listen this law of isomorphism. ನೋಡಿಲ್ಲ ಐಸೋ ಅನ್ನೋ ವರ್ಡ್ ನಮಗೆ ಹೇಳುತ್ತೆ. ಐಸೋ ಅಂತಂದ್ರೆ ಏನ್ರಿ ಐಡೆಂಟಿಕಲ್ ಅಥವಾ ಐಸೋ ಅಂದ್ರೆ ಏನ್ರಿ ಸಿಮಿಲರ್, ಹೌದಾ? ಐಸೋಮಾರ್ಫಿಸಮ್ ಲಾ ಏನ್ ಹೇಳುತ್ತೆ ಹಾಗಾದ್ರೆ ಈ ಐಸೋಮಾರ್ಫಿಸಮ್ ಲಾ ನಮಗೆ? So this law of isomorphism states that the compounds having the same structure or identical crystal structure have similar constitution and chemical formulae. Listen the explanation carefully. Example here, one is a potassium sulfate and second one is a potassium chromate. Suffix word ate, chromate. One is potassium sulfate, second one is potassium chromate. Here K2SO4 sulfur atom. This sulfur atom, it is attached to 2 potassium and 4 oxygen. 2 plus 4 how much? 6. That means what is the valence of sulfur atom here? 6 is the valence of a sulfur atom. Similarly, in the second case also, chromium, this central metal atom, it is bonded to 2 potassium and 4 oxygen. And once again 2 plus 4 equal to how much, students? So 6. ನೋಡಿ ಇಲ್ಲಿ 2 plus 4 ಏನಾಯ್ತು 6 ಆಯ್ತು, ಇಲ್ಲಿ 2 plus 4 ಏನಾಯ್ತು 6 ಆಯ್ತು. ಅಂದ್ರೆ ವ್ಯಾಲೆನ್ಸ್ ಆಫ್ ಸಲ್ಫರ್ ಬಂದ್ಬಿಟ್ಟು 6, ವ್ಯಾಲೆನ್ಸ್ ಆಫ್ ಕ್ರೋಮಿಯಂ ಬಂದ್ಬಿಟ್ಟು 6. ಅಂದ್ರೆ ಇದ್ರದ್ದು ಸ್ಟ್ರಕ್ಚರ್ ಸೇಮ್ ಇರುತ್ತೆ, ಇದ್ರದ್ದು ಸ್ಟ್ರಕ್ಚರ್ ಸೇಮ್ ಇರುತ್ತೆ. ಹೌದಾ? ವ್ಯಾಲೆನ್ಸ್ ಕಂಬೈನಿಂಗ್ ಕೆಪಾಸಿಟಿ ಸೇಮ್ ಇದೆ ಅಂತಂದ್ರೆ ಸೊ ಬೋತ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ ಐಡೆಂಟಿಕಲ್ ಕ್ರಿಸ್ಟಲ್ ಸ್ಟ್ರಕ್ಚರ್, ಸೊ ಬೋತ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ ಸಿಮಿಲರ್ ಕ್ರಿಸ್ಟಲ್ ಸ್ಟ್ರಕ್ಚರ್ ಅಂಡ್ ಬೋತ್ ಆರ್ ಹ್ಯಾವಿಂಗ್ a similar constitution and chemical formula. This is the fourth important method. So this is about the fourth important method of determination of atomic mass of an element, students. So all these four are different methods of determination of atomic mass of an element. And you please remember all these four important methods, and all these four methods are important for the competitive examination point of view, students. Okay, the first method is Dulong and Petit's method or Dulong and Petit's law. It is applicable only for the solid elements. Second one is called as the vapor density method. It is applicable only for the elements whose chlorides are volatile. The third one is called as a specific heat method, and this specific heat method it is applicable only for the gaseous elements. And the last one is called as the isomorphism method. Yes, tell me students, what is the statement of law of isomorphism here? It states that the compounds having identical crystal structure or similar crystal structure have similar constitution and chemical formula. This is the statement of law of isomorphism, students. Is there any doubt in all these additional information? Is it clear, students? So we'll move to the next important concept, that is nothing but the methods of determination of molecular mass of the chemical substance, students. So the methods of determination of molecular mass. So under this methods of determination, once again we have four important methods of determination of molecular mass of the chemical substance, students. So out of these four important methods, the first method is the diffusion method, second one is called as a vapor density method, third one is called as a Victor-Mayer method, and the fourth category we call it as a colligative property method. The determination of atomic mass of an element also we use four important methods. Even in case of molecular mass also, under the heading methods of determination of molecular mass, four important methods are used. And out of these four methods, the first method is the diffusion method. Listen this first method carefully, students. Diffusion method. So this method it is applicable for gaseous substances. It is applicable for the gaseous substances, students. And according to this diffusion method, according to this diffusion method, the ratio of rates of diffusion of two gases is inversely proportional to the square root of their molecular masses. So this is regarding the diffusion method, students. You please listen the explanation carefully. The rates of diffusion of two gases is inversely proportional to the square root of their molecular masses. Here M1 and M2 indicates molecular masses, whereas R1 and R2, small r1 and R2 indicates the rate of diffusion, the rates of diffusion of two different gases, students. So this is the first important method used to determine the molecular mass of the chemical substance, students. So I repeat the explanation here. According to the diffusion method, so the ratio of rates of diffusion of two gases is inversely proportional to the square root of their molecular masses, and this is the mathematical representation. Small r1 divided by r2 is equal to square root of m2 divided by m1. So this is the first important method, students. And now coming to the second important method. The second method is vapor density method. And once again, this second method is applicable only for the gaseous substance, students. See, the previous method is also applicable for gases, and the second method is also applicable only for the gaseous substances. And here, vapor density method. Vapor density. See, vapor density means it is nothing but the density of vapor in relation to that of hydrogen. That is nothing but vapor density, students. Listen the word vapor density carefully. So vapor density means density of vapor in relation to that of hydrogen. That is nothing but vapor density. And this vapor density, it is defined as, the vapor density is defined as the mass of certain volume of a substance, the mass of certain volume of a substance divided by mass of same volume of hydrogen. That is nothing but vapor density. Please listen this vapor density concept carefully. So what is mean by vapor density, students? The density of vapor in relation to that of hydrogen. And this vapor density, it is defined as the mass of a certain volume of a substance divided by mass of same volume of hydrogen. That is regarding the vapor density, students. And here, according to this vapor density method, the molecular mass of the chemical substance is calculated by using the formula molecular mass equal to 2 into vapor density. We can calculate the molecular mass by using this expression. So this implies vapor density is equal to molecular mass of the chemical substance divided by 2. Okay, we can calculate vapor density by using molecular mass of the chemical substance, and we can calculate molecular mass by using the vapor density of the chemical substance, students. So this is about the second important method called as a vapor density method. The first method is a diffusion method, is applicable for gaseous substances, and the second method is a vapor density method. This one is also applicable only for the gaseous substances, students. Is there any doubt in both the cases? Both the methods are clear. And now coming to the third one. The third one is nothing but Victor-Meyer's method. The third one is nothing but Victor-Meyer method. And this method, it is applicable for volatile liquids or volatile solids. Listen the condition for this method carefully. The first two methods are applicable for the gaseous substances, whereas the third method is applicable for the volatile liquids or volatile solids, students. And please recall the term volatile. Volatile substance means the chemical substance one which easily gets evaporated. Such type of the substances are called as volatile substances. And already we discussed this volatile, so in the atomic mass part. ಹೌದಾ? ಸೊ ಇಲ್ಲಿ ನೋಡ್ರಿ, ಈ ಮೆಥಡ್ ಏನಿದೆಯಲ್ಲ, ಇದನ್ನ ನಾವು ವಾಲಟೈಲ್ ಲಿಕ್ವಿಡ್ಸ್ ಗೆ ಮತ್ತೆ ವಾಲಟೈಲ್ ಸಾಲಿಡ್ಸ್ ಗೆ ಅಪ್ಲೈ ಮಾಡ್ತೀವಿ. This Victor Mayer's method, it is based on the Dalton's law of partial pressure and Avogadro's hypothesis. Listen this point carefully. This third method, it is based on the Dalton's law of partial pressure and Avogadro's hypothesis. Avogadro's hypothesis, 22,400 cm cube of vapor of a substance is nothing but molecular mass of the chemical substance. Students, you please listen this third important method, how to calculate the molecular mass of the substance according to this third method, students. So 22,400 milliliter or 22,400 centimeter cube of vapor of chemical substance is equal to molecular mass of the chemical substance, students. So this method, it is based on the Dalton's law of partial pressure and the Avogadro's law or Avogadro's hypothesis. And you please recall the laws of chemical combination. In that laws of chemical combination, the fifth law is Avogadro's law. And according to this Avogadro's law, equal volume of different gases are measured under similar conditions of temperature and pressure. Or equal volume of different gases contains same number of particles under similar conditions of temperature and pressure, students. See, equal volume, the standard volume is 22,400 centimeter cube or 22,400 milliliter or 22.4 liter or 22.4 decimeter cube. You please recall the volume concept. Nodri, 22,400 cm cube is equal to 22,400 milliliter. Cm cube equal to milliliter. 22,400 cm cube means it is nothing but 22.4 dm cube. Howda? Dm cube means it is nothing but liter. 22.4 liter, students. So according to this Victor Mayer method or based on the Dalton's law of partial pressure and the Avogadro's hypothesis, 22,400 milliliter of vapor of a chemical substance is nothing but the molecular mass of the chemical substance, students. So this is about the third important method of determination of a molecular mass of the chemical substance. And now coming to the last method, the fourth important method of determination of molecular mass, that is under the heading colligative property method. Listen, the fourth important method, colligative property method, and this method, it is applicable for non-volatile solid substances. The fourth method is applicable for volatile liquids or volatile solid, whereas colligative property method is applicable for non-volatile solid substances, students. Here we use the word non-volatile, the substance one which does not easily gets evaporated. In such cases we call it as a non-volatile substances. ಹೌದಾ, ಇಲ್ಲಿ ವಾಲಟೈಲ್ ಅಂತಂದ್ರೆ ಸಬ್ಸ್ಟೆನ್ಸ್ ಈಸಿಯಾಗಿ ಎವಾಪರೇಟ್ ಆಗ್ತವು. ನಾನ್ ವಾಲಟೈಲ್ ಅಂತಂದ್ರೆ ದ ಸಬ್ಸ್ಟೆನ್ಸಸ್ ವಿಚ್ ಡಸ್ ನಾಟ್ ಈಸಿಲಿ ಗೆಟ್ ಎವಾಪರೇಟೆಡ್. ಸಚ್ ಟೈಪ್ ಆಫ್ ದಿ ಸಬ್ಸ್ಟೆನ್ಸಸ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ಅ ನಾನ್ ವಾಲಟೈಲ್ ಸಬ್ಸ್ಟೆನ್ಸಸ್, ಸ್ಟೂಡೆಂಟ್ಸ್. And the colligative property method, it is applicable only for the non-volatile solid substances, students. And here colligative property. Colligative property means the property of a solution which depends on number of solute particles but not on the nature of solute particles. So that itself we call it as a colligative property, students. You just remember this method, okay, because once again we'll discuss this colligative property in detail in the PUC second year under the solution chapter, students. ನೋಡಿ, ಏನು ಕೊಲಿಗೇಟಿವ್ ಪ್ರಾಪರ್ಟಿ ಮೆಥಡ್ ಏನಿದೆಯಲ್ಲ, ಇದನ್ನ ಸೆಕೆಂಡ್ PUC ಒಳಗ ನಾವು ಸೊಲ್ಯೂಷನ್ ಚಾಪ್ಟರ್ ಒಳಗ ಡಿಟೇಲ್ ಆಗಿ ಸ್ಟಡಿ ಮಾಡ್ತೀವಿ. Colligative property ಅಂತಂದ್ರೇನು, on what basis the colligative properties depends, and what are the different types of colligative properties, and how to determine the molecular mass of the chemical substances by using this colligative property method. Students, ಅಲ್ಲಿ ನಾವು ಡೀಟೇಲ್ ಆಗಿ ಕಲಿತೀವಿ. ಇಲ್ಲೇನಿದೆಯಲ್ಲ, ಜಸ್ಟ್ ರಿಮೆಂಬರ್ ದಿ ಟೈಪ್ಸ್ ಆಫ್ ಮೆಥಡ್ಸ್ ಆಫ್ ಡಿಟರ್ಮಿನೇಷನ್ ಆಫ್ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್. ಹೌದಾ, ಇದನ್ನ ಜಸ್ಟ್ ನೆನ್ಪಿಟ್ಕೊಡ್ರಿ. ಕೊಲಿಗೇಟಿವ್ ಪ್ರಾಪರ್ಟಿ ಮೆಥಡ್ ಏನಿದೆ ಅಲ್ರಿ, ಸೊ ಇಟ್ ಈಸ್ ಅಪ್ಲಿಕೇಬಲ್ ಓನ್ಲಿ ಫಾರ್ ದಿ ನಾನ್ ವಾಲಟೈಲ್ ಸಾಲಿಡ್ ಸಬ್ಸ್ಟೆನ್ಸಸ್. And you please remember, colligative property, it is nothing but the property of a solution. The property of a solution which depends only on the number of solute particles but not on the nature of a solute particle. Such properties are called as a colligative properties, students. And under the heading colligative properties, we have 4 different types. Relative lowering of vapor pressure, second one is elevation in boiling point, third one is depression in freezing point, and the fourth one is osmotic pressure. All these are nothing but properties of a solution. All these 4 are nothing but colligative properties. ನೋಡಿ, 4 colligative properties ಬರ್ತಾವೆ. ಸೊ ಯಾವ್ಯಾವ್ರಿ 4 ಪ್ರಾಪರ್ಟೀಸ್? ಒಂದು ರಿಲೇಟಿವ್ ಲೋವರಿಂಗ್ ಆಫ್ ವೇಪರ್ ಪ್ರೆಷರ್, RLVP ಅಂತ ಕರಿತೀವಿ. ಸೆಕೆಂಡ್ ಒನ್ ಎಲಿವೇಶನ್ ಇನ್ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್, ಥರ್ಡ್ ಒನ್ ಬಂದ್ಬಿಟ್ಟು ಡಿಪ್ರೆಷನ್ ಇನ್ ಫ್ರೀಸಿಂಗ್ ಪಾಯಿಂಟ್, ಫೋರ್ತ್ ಒನ್ ಬಂದ್ಬಿಟ್ಟು ಆಸ್ಮೋಟಿಕ್ ಪ್ರೆಷರ್. ಹೌದಾ? ಸೊ ಈ ಎಲ್ಲಾ ಕಾನ್ಸೆಪ್ಟ್ ನಾವು ಡೀಟೇಲ್ ಆಗಿ ಸೆಕೆಂಡ್ PUC ಒಳಗ ಸೊಲ್ಯೂಷನ್ ಚಾಪ್ಟರ್ ಒಳಗ ಕಲಿತೀವಿ. Okay, here you just remember the method of determination of molecular mass. Okay, so all these are 4 important methods of determination of molecular mass of the chemical substance. Yes, students, is there any doubt in these methods of determination? All these 4 methods are clear. So the first method is diffusion method, which is applicable for gaseous substances. Second one is called as a vapor density method, which is also applicable only for the gaseous substances. The third one is called as a Victor-Meyer's method, and this method is applicable for the volatile liquids or volatile solid substances. And the last method is called as a colligative property method, and this method it is applicable for the non-volatile solid substances. Students, okay, so all these are nothing but methods of determination of molecular mass of the chemical substance. Is there any doubt in this concept? So this is about the methods of determination of atomic mass and methods of determination of molecular mass of the chemical substance. And these 2 concepts are not there in the NCERT book. And these 2 concepts are additional information from the competitive examination point of view. Okay, so ಎರಡು ನಾನು ಏನು ಹೇಳಿದೆನಲ್ಲ, ಮೆಥಡ್ಸ್ ಆಫ್ ಡಿಟರ್ಮಿನೇಷನ್ ಆಫ್ ಅಟೋಮಿಕ್ ಮಾಸ್ ಮತ್ತೆ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್, ಎರಡೂ ಕಾನ್ಸೆಪ್ಟ್ ಏನಿದಾವಲ್ರಿ, ಎಡಿಷನಲ್ ಇನ್ಫಾರ್ಮೇಶನ್ ಫಾರ್ ನೀಟ್ ಅಂಡ್ JEE. Is it clear, students? Is there any doubt here? Based on the today's class, the today's assignment is you just make a list of methods of determination of atomic mass and method of determination of molecular mass of the chemical substance. Okay, so atomic mass of the methods, ಅದರ ಕೆಳಗೆ ಯಾವ ಮೆಥಡ್ ಬಂದು ಅದರ ಏನು ಫಾರ್ಮುಲಾ ಅಂತ ಅದನ್ನ ಬರೀರಿ. ಸೇಮ್ ಥಿಂಗ್ ಮೆಥಡ್ಸ್ ಆಫ್ ಡಿಟರ್ಮಿನೇಷನ್ ಆಫ್ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್ ಒಳಗ ಯಾವ್ದು ಮೆಥಡ್ ಇದೆ, ಯಾವ್ದಕ್ಕೆ ಅಪ್ಲಿಕೇಬಲ್ ಆಗುತ್ತೆ, ಅಂಡ್ ಹೌ ಟು ಕ್ಯಾಲ್ಕುಲೇಟ್ ದಿ ಮಾಲಿಕ್ಯುಲರ್ ಮಾಸ್. ಓಕೆ, ಸೊ ಅದನ್ನ ನೀಟಾಗಿ ಸೊ ಬರ್ದು. This is the today's assignment students. Okay, so with this I conclude my today's class. Thank you.